Welcome to Chapter 3. So Chapter 3, we're diving into scatter plots and correlation, with our big idea being able to describe relationships. So the beginning of describing relationships is being able to determine what is explanatory and what is a response variable, okay? Because a lot of statistical studies are talking about the relationship between two variables, not just one variable in isolation. So what we want to know is how to determine response versus explanatory. So a response variable measures the outcome of a study, and the explanatory variable may help explain or influence change on that response variable. So the explanatory variable is what's causing the change. The response is what is being changed, is what we're measuring. So let's take a look at this. How does drinking beer affect the level of alcohol in our blood? The legal limit for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, the police officer measured their blood alcohol levels. So what we're looking for is explanatory versus response. Which variable is explanatory? Which is the response? So here, the explanatory, they're having different numbers of cans of beers. Okay, so to me, the explanatory variable is probably going to be the amount of beer. And then what is being changed? What are we measuring? Well, we're measuring their blood alcohol content, their BAC. That's what we think is going to be affected by the number of beers that these people are drinking. The National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. Sociologist looks at the data with the goal of using information about debt and income to explain the stress level caused by college debt. All right, so again, we're looking for explanatory, and we are looking for response. All right, so their goal is using amount of debt and income to explain. Okay, so to me, that's being pretty explicit that that is what we believe is causing the change, right? So the explanatory variable is amount of debt and their income. Okay, and what is that causing change in? What is responding to that? Stress. Okay, so stress caused by debt. Okay, so again, it's a pretty easy concept. We just have to make sure that we're good at labeling explanatory versus response. Now, there are some times where there isn't an explanatory and response variable, okay? So that will come up occasionally. And for that, you can look at one really good example, married couples. Height of the female, height of the male, okay? And if you're looking at it like that, one isn't causing the other. One's height isn't causing the other one's height, okay? So in that one, there'd be no explanatory and response variable because one isn't really causing the other. So next paragraph. In many studies, the goal is to show that changes in one or more explanatory variable actually cause changes in response variables. However, other explanatory response relationships don't involve direct causation. So that's why some of them you can look for a relationship without looking for cause and effect. So now, of course, in statistics, we're always looking for how can I graphically display this data, okay? How can I visualize this data? When we're dealing things with two quantitative variables, the best way is a scatter plot, okay? So to make a scatter plot shows the relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis. That's going to be the explanatory variable. And the values of the other appear on the vertical. That's going to be the response. Each individual in the data appears as a point on the graph. Now you guys have all seen this before. You saw it in Prob and Stats, you saw it in Algebra 2. So this isn't going to be shocking to you, okay? This should not be new to you. So the first thing you want to do is figure out which is explanatory and which is the response, okay? So looking at our example, make a scatter plot relationship between body weight and backpack weight. So what I would probably say is your body weight would be explaining how heavy of a backpack you can carry, okay? So I'm going to use the backpack or the body weight to explain how heavy of a backpack can these individuals carry, all right? So taking a look at this, now I'm going to plot those points. So 120 and 26 would be right there. 187, 30 would be about here. 109, 26 would be about here. 103, 24, about there. 131, 29. 165, 31. 158. Oh, I'm sorry. That one should be a little bit higher. That was 35. 165, 35 would be more up there. 158, 31 would be about there. 116, 28 would be about right there. All right. And the neat thing is, you can actually get the calculator to do this for you as well. Okay, so again, I know you guys know how to do this by hand, but let's also review how to do this in the calculator. Okay, so in the calculator, if you go in, so whenever we're inputting data, okay, we always go into stat list. Now this time, I'm going to need two different lists. List 1 is going to be all of those X values that I identified. Okay, the explanatory or the X goes in list 1. The Y values or the response variable goes in list 2. Okay, so this is the first time we're dealing with two different lists because we're pairing this data together, okay? These are my X's, these are my Y values. All right, so stat plot. Whenever we're doing anything graphical in the world of APS statistics, we go to stat plot. I'm going to want to turn it on. This is already showing me a scatter plot. This is telling me my X's are in list 1, Y's are in list 2. Of course, when all of that is set up, now just zoom stat. And you see roughly the same thing that we just graphed by hand. Okay? So, looking at that, now let's talk about how can we describe it. So we took the time to graph it. Now let's talk about how can we describe it. So examining scatter plots. So back when we were describing quantitative data, we talked about SOCs, right? Now we have a new format, okay? Now we're going to be using something called FODs as an acronym to help us remember how to do this. Okay, so the F is talking about the form. Is it taking a linear shape? Is it a curved shape? O is for outliers again. So are there any striking departures from the pattern? Direction, is it negative or positive? Strength, is it weak, moderate, or strong? So just like with socks, we need to make sure we hit in some way, shape, or form all of these. Now, there is a really nice sentence structure, okay? So here, our sentence structure is going to be there is a blank, blank, blank. So strength, direction, form, correlation between the explanatory variable and response variable. And then, of course, if there's any striking features, that you would note them at the end. So if you can memorize this structure sentence, you're going to be really, really well off. All right? So let's take a look at this, okay? And again, let's do our scratch work for FODs. Our form, I'd say this is pretty linear. Outliers, I'm not seeing anything that strikes me as a major outlier. So I'm going to say, I'm not noticing any. Direction, notice it's increasing as you go from left to right. So that's going to be positive. And strength, I think this is either moderate or strong. We're going to eventually learn a numerical calculation for how to describe that. But for now, you put moderate, strong, that works. Now, just like when we did socks, so we have our scratch work, but now whenever you're actually describing it, that's why I gave you that sentence, okay? Because I want you to be able to communicate everything in words. So there's a moderately strong positive linear correlation between body weight and backpack weight with a potential, it looks like I did note a potential outlier as something that might deviate a little bit. A potential outlier at 187.30. The student is carrying less than what we'd expect given his or her body weight. All right, so if you do notice an outlier, what you'll want to do is note where it is and note what's unique about it, what's strange about it. So in this case, that point, if we look at that point, so let's go back. That is this point right here. He's carrying less than what we would expect him to. Okay, so if he was following the rest of the pattern, we'd expect his point to be somewhere up there. And so again, this is kind of what takes used to getting used to. Because if you notice, even right away, I was like, I don't see anything striking, like really striking about this. But it's getting in that habit of thinking, well, that point really does belong higher. So when you're looking at these outliers, describe where it is, and then also be able to describe what's unique about it. Why are you saying that this is not following the rest of that pattern? So let's get some practice to doing this with some other examples, all right? And again, what we're looking for is FODs. And so if you want to do your scratch work, so here, FODS. So here for form, I'd say, basically linear, but there is some slight curvature to it, okay? So now I can't remember what I hid underneath the white block there, but I'd say roughly linear, but there is a little bit of curvature to it. That would be appropriate to mention. Outliers, this time I'm definitely not noticing any definite outliers. Direction, still positive, and I'd say this is still a strong relationship. Okay, so once you have all of that, once you have your scratch work done, then I would write it out. There's a strong positive, slightly curved association between years of experience and income. Okay, so again, always using the format of that sentence structure. What about Old Faithful? We're looking at this one. I'm gonna give myself a little more space up here. So again, let's talk about FODs. So the form, again, you can tell that it's linear. Now this time something striking that I notice is that there's two clumps to it, okay? So again, in that form, if it's basically linear, but you're noticing anything unique about that form, again, feel free to note that for me, okay? In terms of outliers, again, I'm not going to note any here. There's none that I can directly tell would be an outlier. Direction, this is going to be positive. Strength, this time for strength, I'm going to say only moderate. I'm not going to call that super strong. There is quite a bit of spread in there. So, see, there's a moderate positive linear association between eruptions during waiting time between eruption duration and waiting time between eruptions. They're two distinct clusters of data. And then I even went as far as to say where those clusters are. The more you communicate, the better. Okay? Again, at least make sure you're catching all four elements of FODs, but it's even better if you're catching extra things in there too. Like in this one, those two clumps are a really good thing to note. And our last example. So here, again, we're going to talk about FODs, F-O-D-S. Form, again, I'm going to say basically linear. And I can't remember if I did or not, but there does look like there may be some slight curvature there. Okay, so again, you could note that. I don't remember if I put it down, but something I'm noticing slightly as I'm looking at it. It's slightly curving downward. So outliers, any striking differences? Again, I can't remember if I noted any or not, but it'd be understandable if you maybe thought that one or that one was a little bit misplaced. Again, if you feel it is, feel free to note it. Okay, again, I can't remember precisely what I did, but if you're feeling like some of those are misplaced, you can put those on there. Here, direction, well, this time it's negative. This time, notice as you're moving left to right, notice all the values are decreasing, okay? Following kind of a negative slope, so we're going to call that a negative association. And then strength, I say this is pretty moderate to strong. They are following a pretty strong pattern here. So there's a moderate to strong negative linear association between age of car and value of car. So in this one, I guess I did not note those as possible outliers. But again, just if there are any that you see, you can feel free to mention them. Just make sure you reference back to the other side about what to do. Okay, note the point, note what is unique about it. My AP exam tip for you. So if you're asked to make a scatter plot on a free response question, be sure to label and scale both axes. Even if you're using your calculator, you do have to make sure you provide a scale. You can't just make a scatter plot without that and your labels, okay? So again, as always, just make sure as you're going through them that you label everything. Don't just copy out what the calculator gives you. So thank you for joining me for this, and make sure you ask me if you have any questions.